In today's experiment, we will be discussing about the wheel rod pendulum. In next few seconds, we will be flashing the problem statement and a standard mathematical derivation required for this experiment. After that, we will come to the experiment. In first case, when the wheel is fixed with rod, wheel is not going to rotate with respect to rod, but in oscillation case, the wheel is going to rotate about the pivot point. On the other hand, second case, when the wheel is free to rotate during oscillations, there is going to be no rotation of the wheel with respect to the pivot point. That's why you can see that there are two different expressions for these two cases. So in today's experiment, we will be exploring these two different cases and try to see that how much is the time period is going to vary for these two cases. This is our experimental setup. Here what you see is there is a wheel and a rod, which is nothing but the front wheel of a bicycle with its fork, and at the end of the fork we have clamped one rod, and this rod is resting on this knife edge arrangement where it can oscillate freely. And this clamp we can move up and down, so that way we can effectively change the length of the pendulum. In first case, the wheel is free to rotate, and we will be measuring time period with this condition. So let us start the experiment for this simple arrangement. In order to minimize the error, we shall count for 20 oscillations. So let us count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 and 20. So for 20 oscillations, it took 29.8 seconds. So that we will be feeding in our this Excel sheet. So for 58 centimeter of effective length, for 20 oscillations, we get 29.8 second. Now we will repeat this experiment 10 times. And what we will do is that at the end we will take average of these 10 readings, and also we will estimate error by taking the standard deviation of these 10 readings. So here is the data for 10 different trials. So we have fed in all this, and what we see is that average turns out to be 29.8 second and the error is 0.4 second. Now we will move to the next part of the experiment. Here for the same given length, we have tied the wheel with the rod. That means now wheel cannot rotate with respect to rod. And for this condition, we will repeat the experiment. So we will observe for time for 20 oscillations, and we shall be repeating the experiment 10 times. So what we see is that in this case, when wheel is fixed with the rod, we are getting average time per 20 oscillations to be 32.4 second, and we have error of plus minus 0.5 second for this case. Now we will change the effective length of the pendulum by clamping the rod at a lower length. So what you can see is that now we have effective length of 41 centimeter, and in this case we will repeat the experiment as we have done earlier. So first we take measurement for 20 oscillations, and we will repeat the experiment 10 times. And in this case, for 41 centimeter, the wheel is free to rotate with respect to rod. So in this case, we see that the average turns out to be 24.9 second with the error of 0.4 second. We see that for free case, now time period has decreased for this reduced pendulum. Now we move to the last part of the experiment. So we tie the wheel with a rod and repeat the experiment. That means we will be taking time for 20 oscillations and repeating the experiment 10 times. So in this case, we see that the average turns out to be 29.7 second with the error of plus minus 0.4 second, and this is larger than the time which we noted down for the free case. So after doing this all experiments, we can conclude following. With the decreasing effective pendulum length, the time period decreases in free as well as in fixed case. We can see that for 58 centimeter in free oscillations, we had 29.8 second. On the other hand, for 41 centimeter for free oscillations, it took lesser 24.9 second. Similarly, in fixed case, for 58 centimeter length, it took 32.4 second. On the other hand, for 41 centimeter, it took 29.7 second. We can also see for a given length, the time period for fixed case is larger. Like for this 58 centimeter, the time required for free oscillations was 29.8 second. On the other hand, for fixed, it is 32.4 second, slightly higher than 29.8. This happens because when we talk about moment of inertia of this pendulum, we have three contributions. One is the center of mass of the rod about the point of suspension, and second is the center of mass of the wheel about the point of suspension, and third, moment of inertia of wheel about its own axis. So this third part contributes only when the wheel is fixed with respect to rod. So that's why we get a larger time for a fixed case. Similarly, we also note the difference between the fixed and free time periods is more for a smaller length. This is because for a smaller length, moment of inertia of the wheel with respect to its axis, that is the last term, is same. But first two term, where center of mass of the rod and center of mass of the wheels are involved, it decreases for the lower length. So that's why we see that for a smaller length, this difference is more prominent. So that finishes the today's experiment.